Hello, ladies and gentlemen. Welcome to another lesson in pre-calculus with Mr. Checo. So here we are going to be working on lesson 2.4, polynomials and rational functions. So let's go ahead and let's get this started. So as we take a look, we have 22 questions. Let's go ahead and open up the first one, take us to the textbook, and see what it is that we are going to be looking at. As you can see, I already have Desmos open, so I'm ready. All right, here we go. Polynomial and rational functions. A linear and a quadratic function are special cases of a more general class of polynomial functions. Polynomial functions are a special case of even larger class of functions, the rational functions. We described basic functions of graph, polynomials and rational functions. All right, polynomial functions is basically every kind of function, guys. So it's a linear function, degree 1, and then it can go all the way up to any kind of degree. So here we have a degree 1. This is going to be a degree 3. So my little hint is that it's always going to be the number of kind of like turns, and then yeah. So here, this one's just linear. Quadratic has one turn, so this is a quadratic with 2 turns. This is a cubic function. 1, 2, 3, 4. This is to the 5th power. This is 1, 2, 3 to the 4th power. 1, 2, 3, 4, 5 to the 6th power, as you can see. Like, I'm just confirming everything. So now we're going to kind of go about it and just look at the information of these kind of things. So here is an example of where we're going to have a break in the function. So when it's less than 0, it's a certain number. When it's greater than 0, it's a certain number, and there is a break. It is discontinuous because we cannot divide by 0. Here, this is an example of a continuous but sharp. So this is going to the left, this is going to the right, but it is continuous. So the graphs touch. All right, cubic regression. Fine with that. Now that I know Desmos can do regression for us, here. A rational function is any function that can be written in this form, where it's a numerator over a denominator. The domain is going to be the set of all real numbers such that the denominator is not equal to 0. So your biggest, most restrictive thing is going to be your denominator. Your numerator could be any kind of function. Your denominator is going to be the problem. Okay, moving on. So here's some graphs where we have them being divided. So this is a rational function. This is an example of another rational function. Here's a, not really a rational, it is a rational function, but it's, yeah, okay. Graphing rational functions, you're going to find the domain where you're going to set the denominator equal to 0 and see what makes it equal to 0, because that's not going to work. Then you're going to find the x-intercepts by making y equal to 0 and x equal to 0 respectively. Find the equations for all vertical asymptotes and so forth. We'll get through this. All right. So I'm going to try my best to show you how to do this by hand, like on pen and paper, but obviously I think it's going to be the easiest to see with Desmos. But I'll be able to explain both of them, and hopefully you guys can follow along. Okay, vertical and horizontal asymptotes and rational functions. So there's a lot of stuff going on here. So first of all, to find the vertical asymptotes, so to find where you're going to have a line going up and down, that means that x is equal to a number. So what you're going to want to do is you're going to want to assume what makes the denominator equal to 0. So suppose n and d, numerator and denominator, have no real zeros in common. If c is a real number such that d of c is equal to 0, which means that makes it undefined, then x equals c is a vertical asymptote at that graph. That's the first case. If n and d have one or more real zeros in common, cancel the common linear factors out and apply case 1 to the reduced functions. So you're still going to end up doing what case 1 is setting the denominator equal to 0. The horizontal asymptote occurs under 3 conditions. The first condition is if your numerator degree is less than your denominator degree. So for example, if this is x to the 3rd over x to the 5th, there's going to be y equals 0 as a horizontal asymptote. If they are equal, then it's the ratio between them. So if this is like 4x squared over 5x squared, then it's going to be 4 over 5. If your numerator is bigger than the denominator, then there is no horizontal asymptote. So this is a little like the 3 cases are tricky, but yeah. Okay, so here, if I compare 3x squared over 2x squared, they have the same degree, which means it is going to have a horizontal asymptote at 3 over 2. So, moving on. Yeah. So 3 over 2 is the horizontal asymptote. And we're going to get to problems like that, but that looks like it's the end of the chapter. All right, so I can X out of my textbook and go straight here. For the given polynomial, find the degree. So this is a degree 1 because there is an X there. The x-intercepts is going to be, well, whatever makes this equal to 0, correct? The x-intercept, so that would be negative 6 over 5. The y-intercept is just going to be 6. Like, this is a linear equation. Nothing complicated here. Should be pretty straightforward. Now, same thing here. This is x squared, so this is degree 2. The x-intercepts are what multiplies to 20 and adds to negative 9. Negative 10 and 1. No. Negative 5, negative 4. So x is 5 and 4. 4 comma 5. The y-intercept is going to be 20. You just plug in 0. Okay, cool. So what's the minimum degree? So here, if you see 1 term, 2 term, 3 term, the smallest this can be is 4 terms. That's the least number in order to have that many hills and valleys. Now, the leading coefficient, because this graph is facing down, it's going to have a negative coefficient. Here, 1, 2, 3, 4. So there are 4 terms. This has to be to the 5th degree, minimum. And then here, because they are facing in opposite directions, because it's an odd number, evens will always face in the same direction, odds will always face in opposite. But look towards which way it's going as the end. So here, my x is going towards negative infinity, which means the graph is going down. It should have been going up. Here, 1, 2, 3, 4, 5. This has to be a minimum of 6. And these graphs are both facing in the positive direction with an even number, so we go positive. What is the maximum number of x-intercepts? 11. 10. 11. 11. There we go. What is the number of x-intercepts? What is the minimum number of x-intercepts at a polynomial degree? Is 11, because when graphed on an odd degree function, contains both negative and what is the minimum number of x-intercepts? Oh, the minimum number would be 0. No, 1. Because an odd function degree contains both negative and positive values. So remember how I said because this is an odd number, they're going to be hiding in opposite directions. So no matter what you do, there is nothing you can do to keep it like in both heading the same direction. So here it has to have a solution because it's to the 11th power. So yeah. Okay, so now here I'm just going to go straight to the calculator. I'm going to do x fraction, x minus 1 over x plus 1. I'm going to zoom in. So there you guys go. So where are my x-intercepts? The x-intercept is 1, 0. 1. And the y-intercept is never. I don't think this is ever equal to 0. I don't think I could plug in 0. No, I can't plug in negative 1. There are no y-intercepts. 1. Negative 1. Set this equal to 0. You cross multiply. That becomes x minus 1. X is equal to 1. Type an integer or a solution. x equals 1. Oh, y-intercepts. Plug in x is equal to 0, negative 1. Okay. Determine the domain. The domain is all real numbers except when x equals negative 1. So the domain is all real numbers except for when x is equal to negative 1. Because if you plug in negative 1, that makes it 0, and you can't divide by 0. Find the vertical asymptote. The vertical asymptote here is, there's one vertical asymptote, x equals negative 1. X equals negative 1, because if you plug in negative 1, it's not good. Okay, the horizontal asymptote, because these are the same degree, this is x over x, it's going to be one asymptote at y equals 1. There we go. There we go. What this graph looks like is negative 1 and positive 1. I think it's this one. This is a negative 1, that's a positive 1. Yep. There's your graph. All right. Let's do that one more time. So here, find the intercepts for the graph. So when x is equal to 0, that gives me 0. What makes this equal to 0? 0. Yeah. 0, 0. What are the y-intercepts? The y-intercept is when I plug in 0 for here, that gives me 0. This graph touches 0, 0. Okay, determine the domain of the x, make that equal to 0. That's all real numbers except x is equal to 1. Find the vertical asymptote here. They're the same degree, so 6 divided by 1 is going to be y equals... I'm sorry. Vertical asymptote is when the denominator is equal to 0. So 1 minus 1 equals 0. So then it is at x equals 1. X equals 1. Find the horizontal asymptote, same degree, so that's going to be y equals 6. And this graph looks like x equals 1, y equals 6, x equals 1 is going to be positive, y equals 6. This is it. Alright, so here, find the horizontal asymptote. To find the horizontal asymptote, I need to set this equal to 0. What makes this equal to 0? I have absolutely no idea what makes that equal to 0. So, what if I were to just create the equation, the fraction 3x to the third plus 5x plus 2 over 4x to the third plus 3x minus 5. That just got so much more difficult so quickly. So what does this graph look like? Looks like that. So we have one horizontal asymptote, one vertical asymptote. So there should be a vertical asymptote at what? What does that look like? 5.7 and 0.76 and 0.76 something. Horizontal. Let's try horizontal asymptote y equals 3/4 because it's the same ratio. 3 divided by 4. Y equals the ratio 3 divided by 4 because they're the same power. That's my horizontal. Oh, that's all it's asking? Oh my god, it's so much easier than I thought. X squared over x squared, that's going to be 1/2. Y equals 1/2. Y equals 0.5. Oh, they want it as a fraction? 1/2. 1 divided by 2. 1 divided by 2. There we go. Here, there is none. This one has no horizontal asymptotes because x squared is bigger than x. Here, you're going to have x squared times x squared, so this is going to be x to the 4th. x to the fourth, which means that there's going to be one vertical asymptote at y equals 0. y equals 0. If c is a real number such that then line x equals c is a vertical. Okay, wait. Is there a horizontal? No, but there is a vertical. Positive 3, negative 3, positive 9, negative 9. There are 4. Negative 9, negative 3, positive 3, and positive 9. Type equations. You guys really know how to annoy someone. X equals, and x equals. There we go. Those are my equations. Here, so they have the same. We have a vertical asymptote at y equals 1, and the horizontal is going to be at x equals, what is that, 3 and 2? So positive 3, negative 2, so it should be at positive 2, negative 3. Has two vertical asymptotes. The leftmost is x equals negative 3, and the right one is x equals 2. Oh, but up here something's going to cancel out. This is what multiplies to 15, 5, and 3. The 3's cancel out. There is 1 at x equals 2. There is one vertical asymptote at x equals 2 because the numerator and denominator, when factored, simplify. I didn't see that. Find the vertical asymptotes here. They both have an x in common. The x will cancel out. That's x plus 2. That's x plus 7 minus 7. So then there should be two vertical asymptotes. The leftmost is at x equals negative 7 and x equals 7. There we go. So just in case you are struggling with like how I'm trying to get these answers really rather quickly, so if you just look at this x squared, and then what is that, plus 2x, and then if we compare it to our bottom function, which is going to be x to the third minus 49x, it really should, so it's going to show you that even when I zoom out, like these are vertical asymptotes right here, one right there, one right there. Now if you're not really sure where it is, you can kind of just like zoom in and kind of figure out like, well, oh, this is 7.1, this is 6.6, what number do you think they're going to come into? And then same thing over here, and if you factor that, x squared minus 49, hopefully that makes sense. And then again, you could always have the viewed example, which is going to find it by doing it, setting it equal to 0. Yep, it's going to tell you step by step how to do it. So here, find the x-intercepts, find the y-intercepts, find in vertical. The x-intercepts, you just set the numerator. Yeah, there's one. It's at 0, 0. Identify the y-intercepts, 0, 0. Identify the vertical asymptote, which means I set the denominator equal to 0, so it multiplies to 4 and adds to negative. What multiplies to negative 8 adds to negative 4. That'd be minus 4 plus 2, which gives me positive negative 2 plus 4. The leftmost is that x equals negative 2, and x equals positive 4. There we go. The horizontal asymptote is going to be the ratio between our leading coefficients, which is going to be 2. So that's going to be y equals 2. Let's keep going. So which one would this graph look like? Y equals 2 is going to be positive, and I don't even remember what the numbers were. Maybe. Sure. But I think you guys get it. Now if I were to draw this on a calculator, what would it look like in the calculator? In a negative 10 by 10 by negative 1. I mean, I'm still thinking it's this one. Make sure you input the correct rational expression. Wait, what? Graph the function instead of viewing the window and using the graphing calculator. All the graphs have the same window size. Choose the correct answer below. How is that any different than this question up here? Is it this one? It's this one. Because it's y equals 2. That was dumb of me. Okay, so write the equation of the lowest degree here. Oh, so what's this? This is just going to be -9, 1, 2, 3, 4, 5. So that's 1, 2, plus 2 minus 9. Plus 2 minus 9. So y equals x plus 2 squared minus 9. Well, your answer is correct. It's not the correct form. Be sure to write the equation for the lowest degree polynomial function and the graph intercepts shown below for this exercise. Make the linear coefficient 1 and 1. So is that going to be 2x plus x squared plus 4x plus minus 5? Minus 5. There we go. Okay, what's this one going to be? This is going to be 1, 2. This is going to be to the third power. So I think it's just going to be x to the third, negative x to the third plus minus 1. Let's see that. Negative 1 because the graph is going down. X minus 1. It moved 1 unit. No. How many units did it move to the right? 1 unit, right? X minus 1 to the third. No. What happened here? 1, 2, 3, 4, 5. X 1. So let's see. If we're smart about this, then let's say that it's going to be x, the first intercept, times x minus 1, the second intercept, times x minus 2, which is that intercept, right? Now that would equal x minus 3x, x squared, minus 3x plus 2. And then you're saying that I would just give everything to the third, to the second, to the x. Go right here, delete all that stuff. Oh, I put a negative. Make that a positive, and make that one a negative. There we go. Cool. Okay, a company's planning to manufacture snowbirds. The fixed costs are $400 per day, and the total costs are $6,000 per day at the daily output of 20 boards. Assuming that the cost per day is linear related to the output, right? And X in the equation for the cost function. Fixed costs are 400 plus wait. So what's 5,600 divided by 20 is 280x. A company is planning to manufacture snowboards. The fixed costs are $400 per day. And total costs are $6,000 per day at a daily output of 20 boards. So then should I just put it as 6, 1, 2, 3 x? Assuming that the total cost per day, C, is linearly related to the total output per day. Write an equation for the cost function. Remember, the cost function for business is the sum of its fixed and variable costs, and B is the cost per unit. Okay, so let's try this again. So we're going to say that it's 400 plus 6,000, 3,000 plus 3,000x, 300x. What is it? 280. Because it's 5,400 divided by 20 boards. 56. There we go. 56. It's okay. Okay. So now the average cost per board for an output of boards is given by that divided by x. So then that would be 400 divided by x plus 280 for me, because I just take each function divided by x. That's correct. So that's the cost per x. Sketch a graph of the average cost function. Average cost function starts at 800. And then eventually it's going to level out to be around 280. So is that 280? That's 100, 200, 300, 280. 280. I think it's going to be around there. It's either this one or this one. What's the difference between that? 500 is y0. What's the difference? Oh, this one goes to 300. This goes to 300. This one goes to 280. This one goes to 280. It's D. You gotta really look at these graphs. What does the average cost per bird tend to as purchase increases? $280. $280. Yep. Table shown per capita shows the per capita consumption of ice cream in the country for selected years from 1900 or 1990. Sorry, couldn't see. What do they want? They want the cubic regression. Please, let's go straight to copy to clipboard. Copy this. Let's put this right into Desmos. Shoot. None of it came over. So let me just get rid of this. Can I delete that? Control all, control copy. Dang, that didn't work. It didn't take it. It didn't take it. Tab space. Nope. It didn't take it. What am I going to do? Uh-oh. I need to get this table. Copy to clipboard, comma. It didn't take it again. Not that. Copy. Nope. Setting. That's not how I did it. How did I do it? Add table. Let's do 19, 1995, 2000, 2005, 2010, 2015, 2020. And now I can go to this table over here, and I should be able to do 16.8, and then it's going to be 18.7, followed by 16.5, followed by 15.5, followed by 16.6, followed by 13.5, followed by 13.8. Regression what do they want? Cubic, 4 decimal places. 0.1235, because 4, 6. And then I have negative 2.810. No, that's going to be a 5. So 2.81, 1, 2, 3. Dang it, that goes up to 110. What's attached to the x? I have a 5. This is so hard to see. 5643.6645, and then the last one is negative 3776835.6. 1990, 95, 2000, 2005, 2010, 2015, 20, 13.8, 13.5, 16.6, 15.5, 16.5, 18.7, 16.8. I'm looking for, let x represent the number of years since, oh, you suck, 0, 0, 5, 10, 15, 20, 25, 30. Point 1. Yeah, now let's get a new regression. Cubic, linear, put it back to cubic. Negative, just changed. Negative 1, 2, 3, 4. 4 rounds up to 5. This one's going to be negative 0.0250. This goes to 0.2140, and this goes to 17.1381. There we go. Okay. Use the polynomial per capita consumption of ice cream is approximately 2037 would be what? 47 years. So if I just go to here and I type in 47 and I hit what if I do y of 40? Can I do y of 47 like that equals? How do I not? What does this say? Y. So can I just put x equals 47? Oh, I gotta hit one more enter. Dang it. X equals 47. And then if I zoom out and look for where 47 is, right there, 20.5. 20.5. Make sure you use a polynomial. 2037, that's going to be 47 years. Round to 1 decimal place. What did I do wrong? 2020, 2030, 47. If I plug in x equals 47 into that equation, I got that right. Per capita consumption. Use a polynomial model from part A to estimate the per capita consumption of ice cream in 2037. Per capita consumption is approximately round to 1 decimal place as needed. 20.5. 20.4. I mean, Yeah, that's the equation. X equals 47. I mean, I'm getting the same. 20.5. 20.6? 23.9. Hold on. Wait a minute. Are you kidding me? If I were to make this 0.5, and if I made this 0.025 and deleted everything behind it, I bet you it's gonna. This is annoying. Okay, let's keep going. 0.2140. So if I delete 2140, and then what is this? 17.1381. Okay. So that's what I had, right? Oh no, this is what I had. I had 25, and then my correct answer is 23.88, which would have been 23.9, using the rounding that they did. So I actually was more accurate with the actual answer than I was. Wow, look at that. That's crazy. That is kind of crazy though. Okay. So there's your answer. I'm not gonna do that one again. In a study of the speed of a mussel conducted in a certain species of frogs on the various loads, the researcher found that what does the approach as x increases? As x increases, this is going to be approaching 25.06. So 25.06. Oh no, 0.06 is it's just the ratio. 0.06 divided by 1. What's 0.06 divided by 1? 0.06. Yep. 0.06 is probably going to be that number right there, right? And it's going to be approaching that. So I would say it's going to be, does it happen quickly or slowly? Does it happen quickly or slowly? Slowly. Table of divorce rates. Let A of X be the number since 1975. Keep it for marriage rates. Copy to clipboard. How would I do this one? This is definitely not going to accept it. Let's duplicate. Oh my god, it accepted it. A regression for y1. Okay, so let's first check this out. Since 1970, so then this one's going to be 0. This one's going to be 10. This one's going to be 20. This one's going to be 30. This one's going to be 40. And then this one will obviously be 50. 50. I want a cubic regression to 6 decimal places. So let's just go 1, 2, 3, 4, 5, 6. That becomes a 1. So 0.12341. X squared is going to be negative 0.12345. Shoot. 5, 6. And then this one is 0.123456. And this one is last but not least 9.18333. At least one of your answers is incorrect. Which decimal did I get? 0.1234556. This is a positive 0.257183. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 30, 110. 1, 2, 3, 4, 5, 6. Yep. And then I don't know which one it is. I'm sure I'm off. marriage rate. Marriage rate. This is how 0.8, 0.0, 0.27581, 0.91. Oh, there was. All right, there was a 3 after that. 1, 8, 3, 3, 3, 3. They didn't show me that 3 that was hidden behind that guy. That's why I got it wrong. Isn't that fun? Sick. Awesome. Now using this formula. Okay. What's the equation? 2. Oh my god. So there's a 3 here. 1, 2, 3, 4. And then that goes up to the 3. This one goes to the 1, 0. So then that's going to be 3, 1, 0. 3, 1, 0. And then x to the third goes to 0.81. So then 1. Graph that. Where's blue? There's blue. I want when x is equal to 34 should be 64. And now we're 64. Which one of these lines is it? It should be the blue line. So I should be at 4.6. 4.6. Hit enter. Beautiful. Awesome. And that was the last question. Okay, so obviously just please be careful. These decimals are going to be really annoying. But other than that, 22 questions. Took me about 42 minutes. Best of luck.